So for my doctoral project, I worked on the past of a place in west central British Columbia. And what I did was I looked at a bunch of case studies where people were fighting about what the pasts of that place were. And this particular place is a very, very shallow written historical record. So in a lot of cases, I was looking at situations where First Nations elders and archaeologists and mining geologists, foresters, ranchers, all kinds of stakeholders were telling different stories about the pasts of this place. And because there wasn't much to go on in terms of traditional archival records, the pasts that they talked about were grounded in physical things. So my first book project was really a study of how people reconstruct the past from physical traces. And I looked at things like fish genetics and geological strata and archaeological sites. These people would fight over these things because they wanted to accomplish something in the present. This was very much kind of public history in the sense that these were people who were in search of a usable past, and those usable pasts were grounded in stuff. And at the same time as I was working on that, this was in the early 2000s, I was also able to start using handheld computers with GIS and GPS to augment those places that I was studying in my fieldwork with layers of digital sources. And out of my graduate program, I was hired into a department with a strong public history program, but also with ties to geography and archaeology. So people were excited about this kind of work. And one of the things that I found really weird was I would go around circa 2004, 2005, and I would tell people at conferences about the kind of stuff I was doing with the handheld computers. And invariably someone in the audience would say something like, oh, well, someone already did that. And I'd be like, this isn't an art project. It's not a stunt. It's not an invention. I didn't invent this stuff. It's an argument, and the argument is this. If a grad student can afford to do this and can learn how to do it, in a few years, everybody will have these things. They'll all be walking around with little handheld devices that tell them where they are all the time with layers of digital sources over the real world. And people didn't necessarily, I think, believe me at the time. So what I want to do today is I want to make a kind of a similar argument, but about something else. And that is, we now live in a world where it's becoming increasingly easy for people to, as Hod Lipson says, for people to rip, mix, and burn physical objects just as easily as we would edit a digital photograph or something like that. And so what I would like to think about is, there's a lot of hype. In fact, there are a lot of ridiculous claims made on behalf of 3D printing and stuff like that. But the argument is still the same, and that is we now live in a world where this kind of thing is increasingly possible. It's possible to make objects that can interact with one another, that can go online and tell the world about their state, that can interact with people, and so on, that can sense the world and respond to the world. And whereas you used to have an advanced degree in electrical engineering to do this kind of work with embedded computers and sensors and stuff like that, now this is easily in the domain where high school students and little kids can do it without too much difficulty. And so my argument really is that now that these things are possible, as humanists of whatever kind of humanists we are, we have to think about how do we use these things to make humanistic arguments? How do you make, for example, a gizmo that communicates a sense of historical consciousness, or some kind of a device or an environment or a setting or an installation that can change the way people think about the past, about their relationships with one another, about their society, about cultural formations, all the kinds of things that we care about in the humanities. How do we build those kind of understandings into devices and environments and so on that make use of these kinds of technologies? And I think these new possibilities are particularly interesting because they kind of articulate with things that we've talked about in the humanities in some pretty weird and murky ways. So for example, historians of science and technology have talked a lot about this kind of classical split between people who worked with their minds and people who worked with their hands. And the kind of denigration, the long multi-thousand year history of denigrating people who do things with their hands and of kind of at the expense of people who do things with their minds. We've got these categories. We've got all kinds of subsequent categories. The distinctions, the value judgments that we place on things that are handmade or bespoke or custom produced in some way versus things that are machine-made. The kinds of people who work with machines versus the kinds of people who create the machines versus the kinds of people who use machines to produce machine-produced stuff for other people. We have all of these kind of social distinctions, kind of hierarchies built up around these distinctions. And a lot of them have to be kind of rethought in our contemporary situation, because these new modes of production, these new kinds of devices, open up new ways of thinking about what it means for something to be handmade, or what it means for something to be mass-produced, or what it means to do things like, shop at Walmart or put something up on Etsy or that kind of thing. So let me go back in time just a little bit. In 2005, I first started talking to our public history grad students, and I said to them, tell me what the future of history is going to be like. What are historians like us going to be doing in the future? And their answer was always some version of the holodeck. So they said, in the future, you'll be able to put on a helmet or step into a special room, and you will kind of magically encounter the past as if it were like a Paramount TV show. And I would say to them, but surely you've noticed that that's not the it's a kind of an interesting part about Star Trek. It's not the most interesting part about Star Trek. The most interesting part about Star Trek is that people all wear uniforms that don't have pockets. And the reason they don't have pockets is because they can kind of walk up to the wall and they can say, replicator, build me whatever I want. And then when they're done with it, presumably they can walk up to the recycler and put it in there and walk away from it. So they don't need stuff. They don't need pockets to put stuff in. So they have replicators. And my students were like, you're crazy. That's science fiction. You'll never be able to make something on your desktop like that. And this is despite the fact that none of them had any, I teach humanities students, I teach history students mostly. None of them had any experience with virtual reality. But for some reason, that seemed like a realistic kind of technology to them. In fact, right around the time I started being able to teach grad students, there were a lot of kind of up-and-coming technologies that spanned this whole continuum from holodeck to replicator. And I think a lot of those technologies were quite, at the time, I think a lot of those technologies were quite interesting. They were becoming more and more accessible. And for me, virtual reality was kind of the least interesting, the sort of brain in the vat scenario was the kind of least interesting thing you might do in the humanities. So I had already had some luck doing kind of low-end augmented reality, and I kept working on that. Every new model car in the past 5 or 10 years has been full of a network of little computers and sensors and stuff that talk to each other in kind of real time so that you have an untrammeled experience of driving. So you don't notice all of the stuff that goes into the anti-lock brakes and the deployment of the airbag and stuff like that, because what the car designers want you to experience is what it feels like to drive. And so there's an entire kind of ecology of computers, sensors, network stuff talking to each other in real time, generating tons of data, also that you don't experience any of these things. And those sensors and computers, those embedded computers and actuators and sensors were becoming more and more accessible and less expensive. There were people experimenting then and now with interfaces that went far beyond the keyboard and the mouse. And so in the past few years, we've done a lot of stuff with Kinect sensors, for example, structured light scanners and stuff like that, because again, the price keeps dropping, the power keeps getting better and better, and so on. And of course, as you know, there were a bunch of open hardware kind of movements who were interested in bringing 3D printing to the desktop affordably. And so around that time, I started working on the RepRap project and trying to build my own RepRap printers. So in the first few years of my coursework, I concentrated with the students on what's called physical computing. And this is the idea that you can build a little computer, maybe some sensors or communications devices or ways of effecting change in the world. You can build that stuff into an object itself. And so we would create a replica or an interface or an installation or something like that, and then we would put little computers in that in order to make it more interactive and fun to be with. And so to help the students get started, I bought a lot of these modules, but what I did was I printed up pictures of each module on a little 3x5 card, and then on the edges of the cards I put glyphs. So if a particular module used an analog input or a digital input, there was a particular kind of glyph. If it created a digital output or an analog output, there was a different kind of glyph. And basically by lining the cards up on the table, the students could build up a little block diagram of something that had some hope of working. Not that it would necessarily work as they thought it would, but at least it was a kind of a step to what sort of things went plugged together with what else. And in the first year that I taught an exhibit design course, the students worked they all worked on projects that had something to do with the sky. So one group of students built this, it was quite a neat interface. They took a cardboard globe and they kind of hollowed it out and they put switches at various places on the globe. And when you press the button on the physical globe, Google Earth would rotate around on a screen and then a display would pop up telling you something that happened. I think there were meteor strikes, something that had happened at that location. And it was really, it's quite fun because of course, Google Earth has that really visceral, dynamic sense of flying into a position, so just kind of being able to press the buttons and fly around the screen. One of the students built a handheld model of Sputnik that had a little computer in it, and it responded to temperature and motion by modulating an audio signal, which is kind of similar to how the original Sputnik worked. Shown on the screen here, one of the groups built some computer simulations of Stonehenge so they could see the shadows and light at different times of the year. And then they built a little clay model that allowed you to control the digital simulation by manipulating the clay model. So that worked out pretty well. The following year, I decided to have the students try to do exhibits that had something to do with William Harvey's studies of the circulatory system. And as you may or may not know, Harvey did a lot of extraordinarily clever experiments, but a lot of his work relied on things like either working with badly wounded bodies, human or animal bodies, or actually doing vivisection. And so trying to communicate the kind of interesting scientific content without getting into territory where, our own particular horror at the methods would prevent people from understanding what was going on in his thinking. And as part of that work, I gave the students access to a lot of stuff that was in my lab. So 3D laser scanners, computer-controlled milling machines, lathes, routers, mold making and casting stuff, and so on. And that was kind of hard to incorporate into my classwork, in part because it turns out that I've found that humanities spaces for making are really hard to establish. So this is a really sad fact that just about every kindergarten classroom in North America is much better equipped for hands-on making than graduate humanities spaces. So doing mold making, casting, you need a sink, you need to not have carpets, you need to be able to build, forms and stuff like that. Some of the other technologies, things like the milling machines and the lathes and the routers and stuff like that, these are computer-controlled machine tools that can be used to build other objects, but they require a lot of expertise to use, and it's not, at least in my setting, it wasn't at all feasible to kind of try to get students who have absolutely no technical background to a position where they can start doing these kind of techniques within a semester or two. The vast majority of my students have no technical training. So a lot of them have never taken a shop class, they've never programmed a computer, they don't know anything about electronics, they've never worked with metals or plastics or resins or anything like that. Often they do have some kind of crafting hobby or interest or some kind of, they've done something like woodworking or something, so I can kind of draw on their interests and their avocations, but it's still the case that most of the students that I see don't come from a background where they've done any of this kind of work before. On the plus side, however, and this is pretty cool, they don't really have preconceived notions. So if I told a bunch of engineering students at the beginning of the year some of the things I have in mind for them, they would balk because they would say, "You're crazy, we're not going to get that done in a year." Whereas my history students, they don't mind at all. With some of my students and colleagues, we've also been experimenting with what we now call pop-up maker spaces. So the idea is to grab a bunch of equipment, computer modules, computers, tools, safety equipment, all that kind of stuff, and take it somewhere where you can actually make things like a garage or a basement or a hackerspace, and run it for a day or two, and then pack the whole thing up. Document what you do and pack the whole thing up. And the first of these workshops we did was in 2009. It was called Hacking as a Way of Knowing, and we did it at a cool art technology center in Toronto called Interaccess. And what happened at this particular workshop was we gave the participants all of this equipment and stuff, but we had this kind of mountain of e-waste that we pulled off the streets of, at the time I was living in a town where a lot of quite wealthy people live, in the kind of Toronto suburbs. And so you could go around on recycling day and you could pull the most amazing treasures off the sidewalk, kind of barely used. You know, if you grabbed a printer off the sidewalk, it would have like a ream of paper in it. They wouldn't even bother to take the paper out before it thrown away, stuff like that. So each group had this challenge, and the challenge was take this mountain of e-waste, take it apart, hack it, do something with it, but try to create an installation or an object or something which comments on the problem of e-waste. Like try to use the e-waste to tell a story about e-waste itself. And we had a lot of really clever projects. I think my favorite one was one that's shown on the left there. A woman named Cindy Parimba's working on it. And her group built a mechanical flower that only blooms under artificial light. So this was really cool. You'd take it under like, you know, neon lights or something that would bloom, and then you'd take it out to natural light and it would kind of clam up because it's a very nice little project. Other people they used like a record player and a couple of inkjet printer mechanisms to build this RSS feed-driven plotter that responded to states of emergency and stuff like that. So really cool stuff. And in the years since then, we've been doing these workshops all over the place. We do a couple each year. I think this year we have at least 7 or 8 of them around North America with various colleagues, both in the US and Canada. And these pop-up maker spaces give us a setting where we can try things out, where we can fail, where we can discover what's going to work and what isn't, and maybe incorporate some of the stuff into our classrooms. So as this software and equipment has become easier to use, one of the things that I found is I actually get much better results from my students if I get them to work in groups of 1 or 2 people. So with too many people on a team project, you get kind of a free rider problem. Whereas if just 1 or 2 people are working on them, the projects tend to be even better than if half the class is working on it. Tim, for example, was interested in how a streetscape in our town changed over time. And so what he did was he built a series of 3D models of the buildings at various points in time on this one block. And then he used software to flatten those models into 2 dimensions, print them out on an inkjet printer, a photo printer, and then fold them back into 3-dimensional objects. So you can get this software that will take a computer model, flatten it into 2 dimensions, print and cut on a computer-controlled paper cutter, and then you can fold it back together. And he also put his 3D models into Google Earth, so he had a little physical computing interface with a slider, so that you could slide back and forth in time and watch the street, you know, evolve over time. A project like that one, like Tim's, that was a couple years ago, depends on a lot of factors, and a lot of them are getting cheaper and easier to use each year. So one of the things that's made a big difference for our work is the freely available SketchUp program. It used to be, for a while it was, a company was selling it, and then Google bought it and gave it away, and now Google has transferred it over to Trimble. So I believe at the moment it's Trimble SketchUp. But basically this allows students with no drafting expertise or no training in drafting, or in most cases in drawing or any of the kind of plastic arts, allows them to do 3-dimensional design quite quickly. So in the matter of a few hours, most students find themselves able to make 3D models of installations when we're doing museum things. A lot of them use it for like dorm room renovation ideas, that kind of thing. They do objects that they want to print out on the 3D printer and so on. Tim's project and a number of other projects that I've done, that students have done in the class and lab over the years, have involved computer-controlled paper cutters. These are also a really neat way to get into this kind of prototyping. For one thing, the material itself is quite inexpensive, but the computer-controlled paper cutters cost a few $100. They're really quick. You can cut an outline from Illustrator or from Inkscape in a matter of a few minutes. And they're very flexible because you can cut thin paper, you can cut sticky back vinyl, decals, thin cloth, kind of plastic backed cloth, metal foils. Some people use them to cut antennas for electrical engineering projects and stuff like that. So, and if you're familiar with the kind of crafting world, there are commercial products that are kind of like this but are less flexible. I think like the Cricut is one, or Cricut is one of these kind of things that some people have used. Here, Mills Kelly at George Mason, Mills Kelly's demonstrating. He had a photograph of some graffiti that he took during field work in Eastern Europe somewhere, and he first of all sort of made that black and white, and then rendered it as a stencil, cut it out on the printer so that he could experiment with one of his classes about the idea of recreating graffiti, not on the George Mason campus, but on some kind of a temporary wall they could put up so they could experiment with working from stencils and stuff like that. That picture was taken at another pop-up makerspace that we did a couple of years ago in Niagara-on-the-Lake. Here's another example of a paper cutter project. Last year, Jesika and Charlotte wanted to create a pop-up book that had something to do with the history of fashion. And so here they were really inspired by the work being done at Leah Buckley's high-low tech group at MIT at the Media Lab. And so what the women did was they prototyped their pop-up book by hand, and they had, for example, a pull tab where you could pull the tab and the model would come down the runway was the idea. But they were able to embed electronic switches in the final version of the project so that when you actually pulled the paper tab, videos would play on the computer beside it. So the idea was both the kind of traditional toy pop-up book, but also pop-up book as an interface for more traditional desktop computing type projects. So if you're interested in this kind of stuff, there's a ton of ways to get into physical computing now. There's a lot of different platforms, and depending on what the student wants to do, whether he or she wants to control a desktop computer or to build a standalone device, whether they want to use battery power or plug it into the wall, whether they need to receive GPS or send phone calls or do tweets or something else, hook it up into a wireless mesh network, whatever they want to do, there are different platforms available. So here's a couple of the kind of contenders. The one that we're going to work with tonight, at the workshop tonight, is Phidgets. That's the one in the center. But let me tell you about Makey first. Makey is relatively new. And what it is it's this neat little system that allows you to substitute something that is conductive. Could be Play-Doh, bananas are popular, miso soup, a tin can, anything that's kind of tinfoil, anything that's kind of conductive. You can substitute that for the key presses or cursor arrow keys or mouse clicks of the traditional keyboard. So a lot of the students in my course last year, a lot of the students went with Makey right away because it's just a really easy way to get something clever going with a kind of a minimum of programming. Phidgets are a commercial product. They're very sturdy. They come with a ton of different sensors. They're easier to get going. They have nice elaborate software libraries, but they're also relatively expensive compared to some of the other options. And then the one that you've probably heard a lot about is Arduino, which, if you've heard about this kind of thing, Arduino is an open source platform with just like a ton of different manufacturers and options and stuff like that. And if you already have some programming experience, Arduino is a great choice. It's less expensive than the kind of other ones. There's way more sensors and so on. The project on the right there is kind of fun. A couple students in my class a few years ago with computer science background did that one. It's basically a little robot duck that flaps its wings and it's got these red eyes. They wired in some LEDs. This eyes flash whenever you send a tweet to it. So it receives tweets and then the commands tell the duck what to do. And as I say, that was a project done by students who already knew how to program. So if you don't know how to program, some of the other ones are possibly a better choice. So at the beginning of the year, I usually tell the students, just think of something crazy, and then don't worry about if you know how to do it or not. And we'll try to figure out if we can do something with the crazy ideas, because better not to limit yourself at the very beginning. And this fellow here, Adrian, he had this great idea. Well, I mean, for some values, great. It depends what you think of this kind of thing. But basically, his idea was, on all of the Canadian money, there's a picture of a prime minister. And he thought it would be really cool if the prime minister, when you pull out your $5 bill or whatever, the prime minister could tell you their story or tell you some historical facts or something like this. As I say, your mileage will vary about whether it's a great idea or not. But we agreed that at the outset, we agreed we would not be able to modify the Canadian money supply. But starting with that, with something that was kind of cracked, Adrian came up with a really neat idea, and that was, why not build a kind of a bill scanner? So as you know, Canadian money is famously different colored depending on the denomination. So what Adrian did was he used a color scanner, so when you swipe the bill over the color scanner, it detects what the color is, and using the color, it knows which prime minister is on it, and then a little display on his laptop could tell the story. Another project the year after Adrian's class, Erica and Caileen I don't know if this was just a misconception or it was just a fun idea, but they basically had this thought that if you could get one of these old school TVs that were the norm before they were born, and if you wiggled the antennas, you might be able to like zoom around in the past and look at past TV shows and stuff like that. So that was their project. And what they did to accomplish this was they camouflaged one of our iMacs. They built that cardboard enclosure around it to look like a wood grain 70s TV with a little antenna on top. And as you move the antenna, the display changes between bursts of static and old TV shows, news clips, and stuff like that. And the way that works is that there is a, hidden inside the antenna box, there's a little potentiometer which can detect the angle of the antenna, and that's what's used via Phidgets, that's what's used to run the program through different news clips and stuff like that. Now I have to say, none of these students have any kind of technical background. So these people are coming to me straight out of mostly history, but sometimes anthropology, library school, stuff like that, Canadian studies. But these are not people with kind of technical background. And so one of the things which I've found is that it's really important that people not get scared off at the beginning of the year. So I've over the years, I've really learned to try to work with non-threatening role models. This person is one of my favorite. She's at the time she was 9 years old. Super awesome Sylvia, who hosts this DI web show on everything that's cool and worth making. And so when my students watch a video of a little girl soldering or programming a computer or something like that, they feel shy about coming up and telling me that they are not able to do that kind of thing. And so this lets everybody get over the hump of feeling like they may not be able to do it. And I should mention that in my particular context, probably about 70 or 80% of my students each year are women. So questions about gender and technology, people's kind of concerns about gendered technology, about which activities they feel comfortable doing or whatever, come up a lot in our discussions. A couple years ago, with my friend Beth Novisky, we decided to, after a couple conversations about gender and making, we decided to work together on a workshop that we co-hosted on wearables and E-textiles. And this was great because Beth brought all the kind of textile expertise to the project, which of course I didn't have, or maybe I shouldn't say of course, but I didn't have it. And so by working with her, again, in one of these kind of pop-up makerspace settings, we were able to figure out some of the things that would be easier for the students to start incorporating into their own projects. And we now have a lot of projects that involve versions of Arduino which can be sewn into clothing and which can even be washed. They use conductive thread instead of wires. You take the batteries out and you can actually wash the Arduino lily pad module or the Flora modules. This is fun. This woman, Sarah, again, no technical training. She's trained as a geographer and a librarian, but she did 2 textiles projects a couple years ago. One is her Homeward bound penguin, which is really fun. It's a little stuffed penguin that has a computer, an electronic compass, some vibrating pager motors, and a battery inside of it. And the way this little guy works is when you point him towards the South Pole, he starts vibrating with excitement because he thinks he's going to get to go home. It's really cute. Her other project there, Starry Night, was this kind of, has a lily pad sewn into it. That's the thing in the upper right-hand corner, little twinkling LED lights. And so if that were hooked up to the internet or something like that, the stars could flash if somebody tweeted or sent her email or that kind of thing. A couple other women in last year's class, Cristina and Stephanie, wanted to make what they called a Besties sweater. And the idea was when you put your arm around your bestie, their heart would light up. It's really cute. And you can see in the center bottom on Stephanie's shoulder, she has a pair of conductive fabric pads that are close together but not touching. And so there's some conductive thread on Christina's wrist, and so when Christina puts her arm around Stephanie, the conductive pad on her wrist closes the circuit on Stephanie's shoulder, and then the lily pad causes the heart to flash on her chest. I'll show you one more textiles project. Paulina wanted to do an exhibit to do with the traditional Cree women's powwow dance. And so what she did was she built a thing called a yoke. That's the multicolored object in her hand. It's kind of like a shawl that you wear during the dance. And in the shoulder of the shawl, there's a Phidgets accelerometer. And so the movements of the person who's dancing along with the exhibit can be compared with the movements of someone dancing on the screen. And so in this case, Paulina contacted her tribal elders to make sure that the exhibit that we were doing didn't violate any of their cultural protocols. So I have a lab where we could do fabrication stuff, and I have a basement and garage where we do more fabrication stuff, but we don't really have a space where we can do kind of reasonable size mechanical prototyping. So our kind of go-to material of choice is cardboard, which is ecologically friendly and which you can do some interesting stuff with. Shane wanted to make this periscope that you could look through and see there's a computer embedded in the display. As you steer the periscope back and forth, the computer display changes. And the way that that was implemented was just with a kind of a pair of switches that could tell which way the periscope was pointing. In addition to cardboard, we have a variety of mostly toy kind of systems that allow people to do mechanical prototyping. So one of the toys that I'm really fond of, and I'll talk a bit about in a second, is Lego techniques. At toy scales, at small scales, you can build very elaborate mechanisms, which is nice. We use some Vex robotics, which is metal. It allows you to build slightly larger things. I'll show you some pictures of those later. And these days, there are more and more relatively small-scale extruded aluminum systems. So if you build something on the scale of a factory or something like that, there's like a whole universe of extruded aluminum pieces that you can put together to build arbitrary shapes and arbitrary mechanisms, basically. And a number of kind of open source hackers and makers have been trying to scale that down to things that would work at the scale of your desktop or at the scale of a lab bench or something like that. And I'll show you some of those later. The thing that's really nice about using a toy system like Lego is that when you're using Lego, you learn lessons that apply not only to that particular toy, but to other systems. So for example, one of the things I like about Lego is that it demonstrates what Stuart Kauffman calls the adjacent possible, and probably people are familiar with this idea from Stephen Johnson, who popularized it a couple years ago in his book. But basically what Johnson says is, he says, the adjacent possible is a kind of a shadow future that hovers on the edge of the present state of things, a map of all the ways in which the present can reinvent itself. What it tells us is that at any moment the world is capable of extraordinary change, but only certain changes can happen. And he says, think of this adjacent possible as like a house where when you open the door and go into a room, the room is kind of created, and then there are some more doors, and the ones that you choose to go through, more rooms are created, and stuff like that. The idea being that at any moment in time, the kind of sets of technologies that we have give us all these combinatorial possibilities, which then, as we explore them, give us other combinatorial possibilities and so on. I think here's a good example of this from Lego. On the left-hand side is the traditional Lego brick, which had pegs on the top and holes on the bottom, and you could stack them. And Lego bricks, as probably most people probably have played with these, they allow you to build things that look blocky, which is, an advantage and a disadvantage. When the company Lego decided that they wanted to create a system for doing more complicated mechanisms, they introduced this line called Technique. And the first thing that they did in Technique was they created the Technique brick, which is shown in the center there. This has the pegs on the top and the holes on the bottom, but it also has horizontal holes. And these horizontal holes allowed Technique bricks to be connected side to side, and it also allowed you to pass an axle through to build clockworks and gearboxes and stuff like that. If you look at more recent, new Techniques kits, however, you'll find that the Technique brick has almost entirely vanished in favor of what's called the beam. And the beam is the thing on the right-hand side. The beam has only the horizontal holes, and the top and bottom pegs have disappeared. And so, as each new Lego brick was invented and then released in a series of kits, there's whole styles of Lego construction that flourished around the possibilities and then kind of disappeared when those bricks disappeared. And the way that we know this is really fun. The way that we know this is because Lego, as with many kind of hobby things, has this huge cult following, and a lot of the Lego designers and makers practice what Chris Anderson calls making in public. So unless you're a Lego fanatic, you probably don't know this, but there are at least 3 or maybe 4 different specialized computer-aided design packages that you can freely download and start engineering parts out of Lego on your desktop. People kids and adults use these to share their plans with one another. There's a global marketplace in Lego parts. There's a place called Bricklink where you can go and they have 180 million parts listed. You can get anything in any color, find out where to get them cheapest. You can buy 1,000 of something in orange if you want it. It's really cool. There are places where people share their own projects. So you'll find online plans and inventories for robotic spiders, Turing machines, computer-controlled plotters, ancient Greek analog computers. Whatever you can imagine, some dedicated fan has built one of these out of Lego and put up a manifest for you. And every single kit that the Lego Corporation has released has its plans online with a complete inventory in a database so you can search by part. So if you pull a widget out of your collection of Lego, you can look that up in a database, and then you can see over 40 years how that part was used. So you can actually look at the idioms that particular designers use. You can not only learn how to use a part, but you can see the changing styles through which that particular part has traveled over the years. Now, this would be awesome if this was just Lego, right? But this isn't just Lego. When a student does this kind of work and they get to know the kind of space of Lego design, the same lessons apply to things like electronics. They're the same kind of CAD packages and databases and things where you can look up parts and collections of idioms and online projects, all the rest of that for electronic systems. It's true for mechanical systems. It's true for computer software. So basically, by playing with construction toys, what a student or person learns is what to expect when they enter kind of a space of socio-technical design. In our earliest forays into mechanical prototyping, our stuff was pretty rough. It was kind of ghetto. So this guy, Jordan, had this, I think, a pretty awesome idea. He wanted to take his tabletop hockey game. I don't know if this is more of a Canadian thing. Basically, it's got little rods in the end. It's kind of like foosball, but with the rods at the end instead of the sides. He thought it would be cool if his tabletop hockey game could replay this goal that was so historic that it was on the cover of his Canadian high school history textbook. Yes, that's Canadian historical consciousness for you. And so what we did to build this robot was we ripped a slider mechanism out of an inkjet printer, that's in the lower right-hand corner, and we hooked up some Phidgets and some Hobby servo motors, and then we literally stuck those servo motors to the control rods with that blue tack putty, the stuff you can use to hang posters on your dorm wall. But it sort of worked. It worked okay. It was fun. This past year, a fellow named Shez Mohammadi wanted to create an exhibit that people could drum along with. So Shez is a drummer, and so he thought, wouldn't it be cool if you could go in and drum to an exhibit instead of reading it or doing something boring? And so what he did was he took one of his own snare drums and he put a vibration sensor into the snare drum so that when the person who's playing with his exhibit hits the snare drum, it extracts the tempo from their drum hits. Then it uses that tempo to control a drumming robot, which we made out of extruded aluminum. I was talking about these little extruded aluminum systems. Extruded aluminum, a Phidgets controller, there's a bunch of little Hobby solenoids there. It turns out that a solenoid, which is the part that actually strikes the resonator, is, for whatever reason, they're really expensive, so we could only afford, since we had to buy a bunch of them, we could only afford little tiny ones. And so the resonators are made out of electrical conduit. So instead of a drum kit, which is what we wanted to robotize, we ended up with what sounds basically like a robotic xylophone, but still the thing can kind of play along with you, which is pretty cool. Like a lot of people, I was pretty excited by the possibility of making a printer that could print stuff on your desktop. I always say that a printer with a 3D printer, you can print anything you want as long as what you want is made out of plastic and smaller than a muffin. So one of my students and I started building these about 5 or 6 years ago. At the time, MakerBot, we bought one of the first MakerBot prototype kits, but at the time, MakerBot hadn't formed yet, so we were building rep RAMs. But over the years, these kits have become, first of all, more widely available. There's plenty of different manufacturers now, and you have a range of choices. So you can buy a kit that you can put together in 2 or 3 hours, all the way up to something that will take you like months to put together and debug if it's the first time you've done one. And what I like to do is I like to get the students themselves to try to build a 3D printer before they use it. Because my feeling is that once the students have gone to the trouble of actually building one, they have a much better sense of how it works and how to debug it if something goes wrong, what the limitations and possibilities are. So in 2012, a bunch of students from the exhibit design class built a MakerBot kit with Devin, my PhD student, and I. And having built that, they were able to use it in their own projects. So this project is kind of fun. Adriana and Lindsay decided that they wanted to make a suitcase that could kind of reflect the immigrant experience. I think that Adriana had just come back from an immigration museum where someone had done something clever with suitcases, and so she was inspired to do this. So they used the 3D printer to print out some nesting design and print out some nesting dolls, which were part of the Russian immigrants in their thing. And the way that the suitcase works is there's an RFID reader. They forged these nice little passports with RFID tags in them. And when you sweep the passport over the bottom part of the suitcase, the display plays a little video and tells you about the particular person whose passport you just scanned. You can see our problems here with fabrication. Spaces, we don't actually have a place for people to do something like paper. It's not a kindergarten classroom, so we can't actually do paper mache at home, or sorry, at school. So Adriana did that in her own home and then brought in pictures to share with everyone. This past year, the students used what was at the time a newly available online web service from Autodesk called 123D Catch to try to do some design work. And what this program does is you take a bunch of pictures with your iPhone or your Android phone or whatever, and you upload those pictures to an Autodesk server, and Autodesk runs some photogrammetry software and sends you a 3D object back. That's how it's supposed to work. What the students found instead was that it's more difficult than it looks. So their attempts to scan museum articles actually failed. And so Shane, in this case, Shane did the modeling himself in SketchUp and then printed it out on one of the newer MakerBot commercial printers. I try to make failure an important part of the course, and it turns out that's quite easy to do, so no worries there. But at the beginning of the year, what I do is at the beginning of the year, I sit the students down and I say, they're all straight A students, which is sad in itself, but I say, look, there's only one way you're going to get a crappy mark in this class, and that's if you try to play it safe. So I would much rather you take on something ambitious and fail spectacularly than that you try and play it safe to get a good mark, because that's the only way not to get a good mark in my class. And unlike art students, who I would love to teach, or engineering students, who I have sometimes taught, history students and humanities students have never been taught to fail at anything. Like, they've never been asked to learn from failure under any circumstances. This is like a terrifying thing for them. So getting the students to kind of embrace failure and use that to move on is a challenge. On the left here, Jasmine is showing us some webcam footage from the middle of the night when she was head desking because she couldn't get her Connect project working. On the right, Jesika has got a screenshot from 123D Catch where they tried to scan the museum installation they were working on, and they ended up with this extraordinarily beautiful art object instead. But what's great for us is not only do they learn from failure, but I learn from failure. Every time we do something and it doesn't work out, I know what to try next. 3D printers have a lot of advantages. One of the things you can do is, of course, print out things that no longer exist or that are kind of weird just so that you can play with them. So like square gears is a nice example of that kind of thing. Let me say a little bit more about that. For me, one of the most interesting parts about doing the lab over the past 5 or 6 years has been I've been working with a PhD student and also with another professor, Robert McDougall. Rob and I have been working with this fellow, Devin Elliott, who's been doing a PhD project with us on the culture and technology of stage magic. And so what Devin has done is he's used the resources of the lab to reconstruct the illusions of golden age stage magic at kind of dollhouse scales. So this is really great. We can, for the price that was, for the cost that it would take to fabricate one kind of full-scale prop or to set up one stage, we can do whole theaters full of little tiny dollhouse illusions. And so we've got these little dolls that can levitate one another and make one another disappear and stuff like that. It's really fun. But what's particularly neat about Devon's work on magic is that people have this sense that magicians never reveal their secrets. It's like everyone knows a magician never reveals their secret. But it turns out that's not strictly true. In fact, magicians spend, as far as I can tell, an inordinate amount of time bragging to one another in kind of trade publications about how they did a trick, or more to the point, about how their competitor is doing their tricks. But here's the really fun thing. If you go in and you take those blueprints, we have a lot of blueprints from magical, Devon's a card-carrying magician, so we have access to archives that we otherwise wouldn't be allowed to see. I know, it sounds funny. So we have access to all these secret blueprints. So if you take the blueprint and you build the object, it does not work. It does not work because the people who designed these, who did the plans, filled them with these hidden gotchas. So unlike most historians, if Devon were just working with traditional text and image sources, he would be like completely misled by the sources. These sources have been designed to lie to people. And I know there are some people who work in places where questions of secrecy or whatever might lead to there being misleading sources. But in general, I think a lot of historians don't deal with sources that have been designed to lie to them and to look as if they're veridical. Another thing we've been working on more recently is, I just put this in to show you the Vex robotics. This is a mechanical sketch, one of many mechanical sketches that Devon has made of this 19th century automaton known as Psycho. Psycho was this card-playing robot that used pneumatics, and here we're using Vex pneumatics controlled by Arduino to pick a card. This is not, we think of these kind of things like sketches. We know, in fact, that Psycho didn't work this way, but by building a series of models that have some kind of mechanical features in common with the original artifact that we're trying to understand, we come to understand various sorts of design features and figure out what was going on with those. Okay, so I've imposed on people's goodwill for a long time, for more than long enough, so let me draw this to a close relatively quickly. Let me say, if this looks fun to you, if you wish that you were sitting around somewhere playing with Lego or robot kits or something like that in the service of humanities research or teaching or just good times, get in touch with us. As I say, we do these kind of workshops all over the place. We have collaborators in Canada, the US, and other countries who are, we're always happy to talk to people who want to make something if you're excited about doing that kind of thing. If it looks fun to you but you don't feel like you're at the place where you're ready to collaborate with people, go online and check and see what kind of resources are out there. There's tons of stuff. Every day it becomes easier to make stuff, to learn how to do electronics, to learn how to make 3D printers, to learn how to program computers. And it also, we have access to all kinds of online services that allow you to design an object, send it away to a manufacturing center, and actually receive the physical object back in the mail. So you can download SketchUp, create something that interests you, send it out to a site like Shapeways or Pinocchio or something like that. You'll actually receive the physical object in the mail a while later. Anyway, thank you very much.
I think it's very interesting, the early quote that we were talking about, this historical perspective of hands, people that work with their hands versus people that work with their minds. How much have you seen, I mean, I assume you interact with other faculty too that are thinking about, you're hoping to get them to consider these ideas. How have they responded to your interests?
That's a really good question. How do other people respond? I found a couple of different responses. So there's one response where people are like, sure, I love this. I love the idea. I'm not sure how I would do it in my own work on X or whatever. And I'm always happy to talk to people who are in that kind of position. It surprises me, and this is not just among my colleagues, but this is oftentimes when we go and do a workshop at a museum or something like that, or with librarians, we do a lot of work with librarians and museums. invariably there will be like 8 people in the room who are like, oh, this is awesome, I want to do something like this here, or oh yeah, let's buy a 3D printer for the library, whatever, or the museum. And there will be someone who'll be like, this looks fun, you know, and they're like really unhappy. And you think, because doing exhibits that aren't fun is a great way to bring traffic through your door, right? Like, but a surprising number of people, and I don't know where this comes from, maybe it is a historical thing, surprising number of people think that if you're having fun, you must be doing something wrong. I think it might be the opposite, but yeah. So that's, yeah. But definitely a lot of kind of faculty engagement comes from people in related disciplines like experimental archaeology, where they rebuild things, artifacts to understand how they worked. Comes from people in places, as I say, like libraries and museums, where there's more of an public outreach kind of component. Comes from people in history of science and technology, where there's kind of a tradition of understanding artifacts internally or experiments internally, as well as through textual sources and stuff like that. Yeah.
I had a question for you. So you spoke a little bit about how some of the proprietary tools are kind of easier to get students on board, especially at the beginning when they're just getting started. And I was just wondering whether you see any tensions in the sort of the open source or proprietary tool dichotomy, and you know, does it bother you or your students to be working with proprietary tools? Do you find as a rule that it tends to be easier to get students on board? What issues and tensions do you see around that issue?
Yeah, that's a really good question. Thanks. There, definitely the kind of trade-offs between doing things open source, open access, open content versus proprietary are important. I mean, one thing about stuff at this level is that if you go far enough down in the stack of turtles, you hit a proprietary layer at some point. Like, there's open source hardware for sure, but like at some point you're working with chips and stuff which may or may not be open source. I've found that I like to try to choose, there are a lot of factors to weigh. For me, one of the factors about using proprietary technology is that oftentimes I can get better kind of technical support across a wider range of platforms. So I was telling Matt earlier, I used to teach a course in processing, which is a free open source language, and I now teach the same material in a proprietary language called Max. And the reason I made the switch was because I would spend half my semester trying to debug Java problems on Windows Vista. And it's kind of like Java developers never cared about Windows Vista when it was a real thing. And now 7 years later, a lot of my students still have Vista laptops. And so that level of, it's kind of the hidden cost of open source, is that you find yourself working across a huge profusion of platforms and stuff like that. That said, I'm currently teaching some courses in proprietary languages and some courses in open source. I'm doing a lot of stuff now with Linux virtual machines, and so they run nicely across different platforms, and I have kind of gotten around some of those problems. The other thing, which is I think important to point out, is that you can write open source code in proprietary frameworks. So for example, I routinely put up my own stuff in languages like Mathematica and Max. Even though those are proprietary languages, nothing stops me from giving away my own code. And that's kind of, I understand that there's a barrier, the kind of pay to play barrier, but yeah, that's the consideration. It's definitely worth thinking and talking about, though. I think it just has to go on a case-by-case basis.
Hi, you talked a little bit about the lack of a compatible space to do some of these projects in. You know, we built a makerspace, you know, with using leftover plywood and stuff like that, and trying to cobble together money for Arduinos and a 3D printer and all of these things. And you know, one of our challenges is approaching the administration and justifying the cost, you know, and understanding that, you know, these spaces harbor innovation in a lot of ways. And I'm wondering if you can speak a little bit more to, you know, what these spaces are and how, you know, because when we approach administration, they say, well, how does it affect research or pedagogy? Like what are the tangible effects from doing these types of projects? And that's hard to do in a way, because a lot of it is intangible, right?
Again, it's kind of like Matt's earlier question. I think this is definitely one of those things one has to do on a kind of case-by-case basis. And I've found there's some people who kind of get it. They're excited about hacker spaces, and they want to try to bring that creativity into the university. There are some people who, for accidental reasons, in my particular disciplinary, or my particular university context, it's archaeologists. So happens that our dean of research is an archaeologist, and so he understands in a way that I might not be able to convince a sociologist, maybe. But at the same time, I would say that I think I personally have probably failed pretty spectacularly at creating a kind of an institutional space. I have no problems getting grants and getting equipment and getting the everything that goes in the lab, but getting someone to say, yeah, we need a space where people can do this kind of thing is, sometimes you literally, that's why we do these pop-up maker spaces, because a lot of us belong to or work in hacker spaces too, and sometimes it's just easier to do it somewhere where people get it. And so I'm kind of on a mission to get university people to realize that kindergarten is a good idea for people who aren't 6. I mean, kindergarten's a good idea, right? It's not just a good idea when you're 6. It continues to be a good idea. But that said, maybe I'm the wrong person to ask. I think other people have done this better than I have, a lot of them. Yeah.
So here at CUNY at Baruch, they've been using very similar tools such as Makey Makes and 3D printers in first-year composition classes.
Oh, neat.
And as I'm sure a lot of us in the room have found, but also I know Richard Miller at Rutgers writes a lot about, is the difficulty students have in inventing something and coming up with something they're interested in. Yeah. And I'm wondering how you help guide students through that invention process, like how to come up with an idea, how to come up with a vision and see it through. I find students are very stunted when you don't give them specific directives occasionally.
Yeah. No, you're absolutely right about that. And in fact, it's in some ways it's much harder, I think, to get the kind of straight A humanities type student to do something precisely because they haven't grown up in not caring about their grades, basically. So I mean, again, one of the things I try to do is I try to get people just to do kind of a lot of brainstorming type stuff. I try to provide rewards and incentives whenever anybody does something wacky or comes up with something particularly fun. So I try to create a space where people at least feel free to kind of come up with those things. In terms of sticking with the project, for whatever reason, I've found it's turned out to be the case that there's maybe kind of one student in, I want to say probably about 10 or 15, who I'm just never quite able to get to take on the right problem. They're either trying to take on something that's so huge that they can never solve it. And I keep trying to say, no, please, rein it in, back it off. Here's a smaller thing that you can actually accomplish. And so for whatever reason, I think some people get kind of paralyzed. And I think that's related to some extent to questions of fear of failure. I think it's related to some extent to kind of perfectionism. Like, again, the students who I wasn't the world's greatest undergrad. In fact, I often tell my students I was like a loser undergrad, and people will write to me years later and they were inspired by the fact that I was a loser undergrad. I'm kind of like, that's not quite the take-home message I was going for, but thank you anyway. I have a lot of kind of sort of sympathy for those people, and I kind of understand, and in some ways I find it harder to understand the sort of straight A people that all of my colleagues are, and that all of our grad students are. But yeah, it's a really hard question though. Yeah, it's a good question. Yeah.
I'm wondering about the objects that are made. Is it mostly the process that you care about, or is there actually care taken of the objects, for posterity, or, what do you do with them?
That's a really good question. So in the process of making, one of the things I really emphasize to the students is process, documentation, conceptual stuff, dead ends that you go down. Try to document all that stuff and get it online in a kind of open access format. The actual physical objects themselves, we almost always have to recycle. And the reason for that is that the kind of electronic modules and stuff that go into them, we kind of can't, we don't get the students to pay for that, and we kind of can't replace them. Some of them will become obsolete over time, but in general, things like the robotic drum, it was a lot of fun, but I will have to take it apart and use the, because the controller's $100, the solenoids were at least $150, the extruded aluminum is $20. So we just can't keep it. And so creating the kind of, and also in this particular class is an interactive exhibit design class for our public history students. The context is more about creating a kind of a convincing demonstration that you could use as a pitch to someone with funding who wanted to mount it as an exhibition. And so in a number of cases, we've had people from our local museums come down, look at the projects, and then say, oh, hey, I'd really like to put that up on display for a couple weeks. And then in those cases, of course, we let it persist. But yeah, we can't curate the objects or keep them in the way that you might if they were art objects. I mean, they are kind of art objects. Like the little duck is still on my shelf because I just can't bear to take them apart. But
you showed a lot of great examples of like people's sort of first forays out into technology. You've created a really, supportive place where they can come in and try out these things. Do people then later incorporate this into their own practice as they continue on? Like, do they have second and third and other things that they've gone on to do? Do they make their interactive thing within this supportive environment and then not when they're not sort of immersed in that?
yeah, that's a really good question. So in fact, I think what people take away with them is, as far as I know, no one has taken a specific project with them and tried to take it to the next level or anything like that. What people I've found do, a certain number of them, is they take the kind of the mentality and the interest with them. So the woman, Sarah, I showed you, who made the Homeward Bound Penguin, Sarah was really cool, actually. She managed to get a job right after that course, in part based on her blogging about that course. She managed to get a job as an interaction design librarian at a small library north of Toronto. And so she had this position for a year where they basically paid her to do fun things with Arduino and stuff like that, and 3D printing, which was really cool. Some of the other students also have gone on to do more, like there was a fellow who was in one of our workshops once who came and built a 3D printer with us, and then he went home and took on a RepRap project. And it took him 6 months, but he built his own RepRap as a result of his interest in doing it. But yeah, in general, I think environment is a lot of these kind of things, and so having access to a kind of cornucopia of modules and stuff like that, and support from people is an important part of it. Yeah. It's a really good question.
Hi. One of the things that struck me, I listened to Joel Silver talk about the Makey, and he put a warning on the box that was basically saying, you're going to learn so much from doing this. So that really excited me, especially how excited he was about it. Why do we stop? It occurs to me that it's like the physical process helps us unlearn. Yeah. Why is it that we stop, do you think, doing those physical things, or do we become scared or fearful? Or
yeah,
what is it that makes us just stop, that we have to unlearn in a way?
Yeah, that's a good question. I mean, I honestly, well, again, this is just my kind of personal experience. Like I felt like the best year of my life was when I was in kindergarten. Like I was people liked me. I could run fast. I wasn't fat. Life was great. And then it seemed like it was horrible until, like about my 4th year of university. So I honestly think that people think, okay, play is for kindergarten, and then as soon as you're in grade 1, they start weeding out the people who are still playing. They weed out the kids who do things differently or think differently or learn differently. Maybe they don't do that anymore. My experience with the system was, the 70s and 80s. I don't know what it looks like now, but I think that must be it. I really think that must be it. Like because the students, I find for me, a lot of the students who have the hardest time with my class are the ones who look the best on paper. These are, you know, kids who went through the International Baccalaureate program and they have the best marks in the class and they're just desperately terrified I'm going to give them a crappy mark, you know, and I, you know, so I don't know, I think it's that system kind of, you know, it's great for the things it does emphasize. It's great for selecting out the people who can learn how to play the game. But yeah, for people who have a harder time learning how to play the game or don't care about the game, you know, those are the people I think that in some ways are more, you know, could be having more fun doing this.
Hi, I'm wondering if you could talk a little bit more about this concept of failure that you're talking about. What do you think your students are getting from it, if that's what you're pushing them to do? And I'm wondering where that fits personally for you as well.
So yeah, so I mean, like the straight A students, I hate failing or making mistakes, but I seem to do it quite frequently. So, you know, I have kind of for me, I have kind of an uneasy relationship with it. For the students, I think what happens is there's a period of anxiety about, you know, how much, does this guy really mean this? You know, if I do something stupid, will I not actually get punished or get a bad mark or whatever? I usually have the students write reflective blogs throughout the term so I can kind of figure out where they're at. And some of them have said things, you know, in the kind of end of the year reflections, which I found really, you know, heartening. Like Adrian, the guy who did the money scanners, at the end of the year in his blog, he said, you know, I keep wanting this to be about a product and I keep learning that it's about a process. And I feel like he had a lot of trouble trying to get the color sensors going, in part because he was trying to read electronic data sheets, you know, and he has a background in not reading electronic data sheets. So you know, so painful stuff, and he just kept going to the forums and trying to learn that stuff. And I think that in the best case, people really kind of feel energized, like they feel like, oh, there's a place like Stack Overflow where I can go and type in my problem and someone will help me solve it. And then there's a real sense of mastery about doing that kind of thing. At the same time, though, it's, you know, it is scary, and it's not what they're being rewarded for in every other course they're taking. So, yeah.
I actually see a lot of change, and I'm very interested in what you're talking about with how you teach your students. I don't do any of this myself, but I have 2 teenage sons who are makers, and I'm seeing a whole new worldview coming through. My whole education was text-based. I think this is a colossal change, and how this will travel out from fun stuff you can do to larger conceptual changes at the university level, I have no idea. Yeah. But there are a lot of these kids.
You know, and I think there's probably, I think you're right about that, and I think there's also a kind of a weird geography in effect, in the sense that I expect if this kind of stuff is happening anywhere, it's happening in New York, it's happening in the Bay Area, it's happening maybe in downtown Toronto, but that, and at the same time, paradoxically, it's happening in small town Iowa, it's happening in places where people, you know, still have to be able to do stuff with their hands, and that's still valued in the educational system. It's the kind of vast in between, you know, downtown New York and downtown small town Iowa. There's like all of those kind of suburban places, like the place where I live, where, I don't know, maybe it's not really taking off yet, or if it does, it still seems like something that's more fringe. But if that's the case, that this is being brought back into the schools, or it has the potential to transform the way that we teach and learn, even just to expand our notions of what we can do. Yeah, that sounds fantastic.
Hi, Bill. I own way more Lego than I ought to. And I had previously used Lego as my right brain alternative to schoolwork. I could go home and play with Lego bricks and sort of refresh my mind. You have just given me an opportunity to get my doctorate in Lego. So I would ask, you know, what relationship do you see the physical modeling world having with some of these humanities studies? Like, for example, when I brainstormed about, well, what kind of computerized Lego thing would I do given what I study? And I thought, well, maybe like a Lego mosaic maker based on a chart or a graph or some way to sort of create a physical analog of something that already can be visualized readily in the computer. But because we're talking about going into the third dimension, into the real space, what are some of the other sort of humanities manifestations of making that you can, I know you brought a couple up that were really interesting, the pop-up book that was an interface into an online space, but could you talk a little bit more about some of the dovetailing you see maker culture having with humanities in specific, maybe literary studies or other sort of non-physical pursuits, and how they might manifest, or how you've seen them manifest in your work to date?
Yeah, that's a really good question. I guess like when I do talk to a lot of people, they say, I think the ones who don't think that we shouldn't be having a good time. The ones who think we should be having a good time say, this looks really fun. I wish I could think of a way to do it in my own work. And I think that I don't know how to draw, but I'd really like to know how to draw. Especially I'd really like to know how to draw like comics and graphic novels. So I've been spending a lot of time just kind of doodling, and I'm not sure if I'm getting anywhere or not. And at this point, I'm actually not sure if or how I would tie that into my research practice. I just like doing it, and I wish I could do it better, and I'm motivated to keep trying it. And I guess in some ways, thinking about what the connection is, or thinking about how what you're doing relates to what you're doing in this other part of your life is in some ways kind of part of the process. And so I'm not sure I have an answer for you. There's a book that came out, I want to say maybe in the 1980s, called Discovering. It was published by Harvard University Press by a guy named Ruth Bernstein. And what he does is he looked at, he must have read like 1,000 biographies of Nobel Prize winners and scientists and stuff like that. And one of the things he does is he looks at what those other people do. And he's got a really neat chart in the book where he shows you a list of Nobel Prize winners. And then he shows you a craft or a hobby or something that they did. And the list is incredible. There's like people you would never imagine. You can't imagine the connection. A woodworker, a welder, someone who made metal sculptures. Some of the connections are more kind of interesting and fun. So forget which fellow it was, one of the fellows who worked with microbiology. In microbiology, you have a little loop which you sanitize and you dip it into a liquid culture and then you put it on your plate with the agar on it. And this guy would make incredibly detailed paintings out of bacteria. And then he would put them in the incubator and pull them out and the little bacteria would have kind of, exploded on his petri dish. And there would be this beautiful little painting there. And Ruth Bernstein's argument is that surely the kind of sort of loving attention that craftspersonship that went into that engagement with the materials must have helped him in some way. Whether or not it helped him, I want to say, discover penicillin or whatever, who knows? But that was the kind of thing. But I don't have a good answer for you other than to say, but if you enjoy playing with Lego, of course you should keep doing that. That's just common sense.
Okay, well, we're out of time for our public lecture. I just want to kind of close by saying that here at the Graduate Center, one of the things I think that distinguishes a lot of the work we're doing within digital humanities is concentrating a lot on pedagogy and thinking about how we teach. And just want to say how impressed I am by your work and your the way you're encouraging your students and making new things possible for them, opening up new doors for them to create things. It's really fantastic to see. So please join me in thanking Bill for this great talk.